One of you said my videos were too short. Today we're going deep, deep enough to make time, planets, and history look like glitches in reality. Imagine falling toward a black hole. To you, time feels normal. To a friend far away, you appear to slow down, fade, and freeze near the edge forever. Are you falling or frozen? The disturbing answer is, both descriptions can be correct. Today, three paradoxes prove reality is stranger than fiction. First, time is not universal. Einstein's relativity says clocks do not all tick at the same rate. Gravity changes space-time, and stronger gravity makes time pass more slowly compared with a clock farther away. Picture a stretchy trampoline. A heavy ball creates a dip, and a marble rolling nearby follows the curved surface. It is not a perfect model, but it captures the idea. Mass reshapes the environment through which everything moves, including time. Near a supermassive black hole, this effect can become extreme. In a carefully chosen hypothetical orbit, 1 hour for you could equal 7 years for someone far away. You finish 1 cup of space coffee while your family on Earth lives through 7 birthdays. But here's the twist. You would not feel time slowing down. Your watch, thoughts, and coffee behave normally. The difference appears only when your clock is compared with Earth's. You're not breaking time. You're taking a different route through space-time. And the frozen falling paradox has an explanation. Light from you reaches the distant observer increasingly delayed and stretched, so you seem to fade near the boundary, yet you cross it in your own time. Relativity does not choose one viewpoint as the only truth. Time depends on where you are and how you move. Two travelers can leave together, separate, and reunite with different ages, not because one clock malfunctioned, but because each followed a different path through curved space-time. This has been measured with precise clocks on airplanes, satellites, and at different elevations on Earth. The black hole version is extreme, but the principle is already part of real technology. Now leave the black hole and visit Venus, where the planet appears to rotate the wrong way. Most planets spin in the same general direction as their orbit. Venus does the opposite, a motion called retrograde rotation. On its surface, the sun would rise in the west and set in the east, but the calendar gets stranger. Venus rotates once every 243 Earth days, yet orbits the sun in about 225. Because those motions combine, one sunrise to sunrise solar day lasts about 117 Earth days. The sun would take months to cross the sky, and a Venus year would end before 2 sunrises were complete. That distinction matters. When people say a Venus day lasts 243 days, they usually mean 1 full rotation compared with the distant stars. For someone waiting from sunrise to sunrise, the actual solar day is shorter because the planet is rotating backward while it travels around the sun. And what would it feel like to stand there? Not peaceful. Venus is around 465 degrees Celsius with atmospheric pressure about 90 times Earth's. Its clouds contain corrosive chemicals. Without extraordinary protection, a person could not survive. The backward sunrise is real, but the destination is brutally unwelcoming. Why does Venus spin backward? A giant collision, solar tides, or changes over deep time may have altered its rotation. We know the motion, the exact origin remains debated. Sometimes science's honest answer is a mystery with several serious possibilities. Now for the human glitch in history. In 1945, Japanese engineer Tsutomu Yamaguchi was in Hiroshima on business when the city was hit by an atomic bomb. He survived, returned to Nagasaki, and 3 days later was there when that city was hit too. He survived again, and Japan later officially recognized him as a survivor of both attacks. It sounds statistically impossible, but impossible is the wrong word. Extremely rare outcomes can happen when timing, distance, shelter, and chance align. He was close enough to be affected, but circumstances spared him from the worst consequences. His story is not a superpower or a promise of fate. It is probability meeting one extraordinary life. The detail that makes the story even more astonishing is that survival did not erase the consequences. He carried injuries and the memory of 2 separate disasters, then spent much of his later life speaking about peace. The lesson is not that statistics failed. It is that statistics describe a population while every individual life unfolds in specific circumstances. And that's the deeper paradox. We want clean categories. Alive or gone, moving or frozen, day or night, possible or impossible. But the universe replaces them with perspective, conditions, and probability. A clock can be normal for you and slow for someone else. A planet can have a day longer than its year. One person can survive 2 historic catastrophes that almost nobody could imagine. Which breaks your brain most? The black hole where both observers are right? Venus with its backward sunrise? Or the survivor whose life became a statistical outlier? Tell me your choice. And if you want more journeys into the places where reality stops behaving intuitively, stay with us and subscribe. The universe is not becoming stranger. We're finally learning how strange it always was.